Good afternoon, ladies and gentlemen. Welcome to this month's Secretary of the Navy guest lecture. My name is Captain Trent, second-year Space Ops student, and it is my honor to introduce to you Bob Cabana, retired Marine Colonel, A-6 test pilot, former astronaut, and current director of NASA's John F. Kennedy Space Center for the past 11 years. Colonel Cabana spent a total of 37 days, 22 hours, and 42 minutes in space, flying 4 space flights on Discovery, Columbia, and Endeavour. Of note, he served as mission commander on STS-88 with NPS's very own Space Systems Chair, Dr. Jim Newman, where they conducted the first International Space Station Assembly mission. Colonel Cabana currently manages all NASA facilities and activities at the KSC. Sir, I want to thank you for taking the time to speak with us. I know there are many in this room who hope to someday follow in your footsteps. Please join me in welcoming Colonel Bob Cabana.
Awesome. Can we get the volume up a little?
The tower is clear.
All right, try and get you going a little bit there. I want to thank Dr. Newman for inviting me to be able to come out and share with you what's going on at NASA and what our future looks like. And to do that, I'm going to talk a little bit about the Kennedy Space Center. Now, this is a map of the Kennedy Space Center as it is right now. The Space Shuttle flew its final mission in July of 2011, the Space Shuttle Atlantis. It landed on a Thursday in July. On Friday, 2,000 contractors got pink slips and walked out the door. We went from a workforce of 15,000 down to 7,500 in 2 years. We went from a program, from a center where everything was paid for by the Space Shuttle, to having not enough money to maintain all the facilities that we had. And we had to define what we wanted our future to be. There are not many times in your life when you get to define what you want your future to be. Most of us end up in positions where we just try and improve on it or keep it going, all right? And when I got to KSC 11 years ago, we still had 12 space shuttle missions to fly out. In my very first all hands, I said, the space shuttle program's going to end. We have to start planning for our future. And that is one of the key things that you as leaders need to do, and that's communicate a clear vision of the future of what you want it to be and get your team to own it, all right? And change is hard. Nobody likes change, all right? So you got to show them something to reach out for, something to grab onto. None of us can get better unless we change. And that's what we did at the Kennedy Space Center. And to do that, you know, it's kind of the monkey bar analogy. You're hanging on to what you got. You know it and you're comfortable with it, but you got to have something even better to reach out for so that you can move on. So what do we do? Let's go over how KSC looks right now. These 2 launch pads, 39A, 39B. Those are the launch pads, actually 39A, all the flights that went to the moon launched off that launch pad. 39B was used for the Skylab missions and Apollo-Soyuz test project. And then the shuttle utilized both pads. I had 1 off of B and 3 off of A. Pad B, to support the Space Launch System, where we're going, exploring, and I'm going to talk more about that, what our program is. To go exploring, we need 1 launch pad, 1 mobile launcher, 1 high bay in the vehicle assembly building, 1 crawler transporter. So we had all this excess capacity that we didn't need. And part of NASA's mission is to enable commercial space operations. And so we said, all right, first off, if we need it for SLS, we got to keep it. If it doesn't support SLS or commercial space operations, we're going to raise it. We're going to tear it down and get it off our books because we can't afford to maintain it. Now, if it supports commercial space operations, we're going to go out with a notice of availability to all our commercial partners saying, hey, does anybody have an interest in using this? Now, this was a new way of doing business, and not everybody was very supportive of it to start with. But we have totally transformed the Kennedy Space Center from being this one-program government facility to be a multi-user spaceport. So I signed a 20-year use agreement with SpaceX for Pad 39A. We signed that agreement in July of 2014. In January of 2017, 2.5 years later, they had their first launch off that pad. Since then, they've had 19 successful launches off that pad, including March 2nd when they launched the Crew Dragon on a Falcon 9 on a test flight to the International Space Station. The shuttle landing facility, not having a shuttle to land there anymore, we didn't absolutely have to have it. I signed an agreement with Space Florida to take over the maintenance and operations of that facility and to commercialize it. Now, they haven't made a lot of progress yet, but it's available for horizontal launch capability. The orbiter processing facilities. Over here, we had 3 orbiter processing facilities that we no longer needed. We have Boeing in one of them. They're building the CST-100 Starliner for the commercial crew program. In the other 2, I've got the Air Force, Boeing again, with the Air Force X-37 orbital test vehicle. Instead of landing at Vandenberg Air Force Base out here, being towed down to, shipped down to Huntington Beach and processed, being shipped across country to Astrotech in Titusville, Florida, where it was encapsulated and then going out to launch, it now lands here on the shuttle landing facility, gets towed over here to this processing facility where it's processed, encapsulated, and rolls out to the pad to launch. Huge savings for our nation, for the Air Force, much better resilience and response time. In the vehicle assembly building in the high bay, I just signed an agreement with Northrop Grumman Innovative Systems for the Omega rocket, a single-stick solid to operate out of one of the empty high bays, and actually they're going to launch off Pad B also. Over here in the industrial area, Lockheed Martin is in the operations and checkout building high bay where all the Apollo spacecraft were processed. That's where they are building the Orion spacecraft that's going to take us back to the moon and on to Mars. And then this is Exploration Park. This is a research and development park that is on U.S. government NASA property, but it's outside our secure perimeter. Space Florida, I signed the lease with them. They've brought in Blue Origin, who is going to be launching down here on Pad 36 Capeside with the New Glenn rocket. We've got Firefly, a Venture-class rocket. We've got OneWeb building satellites there. And we are continuing to grow. I have over 90 different agreements with academia, other government agencies, and industry. So these are the programs that I have at the Kennedy Space Center. Commercial Crew Program, Launch Services Program. They provide all the expendable vehicles for NASA's science missions. Exploration Ground Systems, that's transforming all the launch pads to support the Space Launch System on Orion. Gateway, this is part of the, we do gateway logistics. I'll talk more about that. And then we do some research and technology at KSC also, even though we're an ops center. So some key milestones. We had the SpaceX Demo 1 on March 2nd. They're now scheduled to be flying their in-flight abort test off Pad 39 on a Falcon 9 here in the next month or so, and they're still trying to make the end of the year for their crewed flight. I'll talk more about that. And then the ICON mission we just launched, I'll show you a shot of that. I'll show you this Orion abort, in-flight abort test. So it's been a really busy year. Now, I think this is pretty cool. You look at these spacecraft, right? In all of human history, 3 nations have sent humans to orbit: the United States, Russia, and China. Today in the United States, we have 3 U.S. companies building orbital spacecraft. Lockheed Martin with the Orion spacecraft for deep space, Boeing and SpaceX, the Crew Dragon and the CST-100 Starliner for commercial access to the International Space Station. Now, what we're doing, we don't own these spacecraft. We are buying a service. We have insight into the spacecraft. We are going to certify them to fly NASA astronauts to the space station, but essentially it's Uber to space. We are buying a ride, all right? They own them, and they can use them for other flights to space if they want to take somebody else also. So a little bit about Commercial Crew. I mentioned that SpaceX demo on March 2nd, hugely successful flight. Uncrewed Crew Dragon to the International Space Station. It all went flawlessly. That launched off pad 39A. That was the first flight of a human spacecraft off that launch pad since Atlantis launched off it in July of 2011. And SpaceX has really made it look fancy. This is the crew access arm to the Crew Dragon, although this launched without crew. And there you can see a great shot of it out on the pad. An excellent use of that facility. Had we not leased that to SpaceX, if we didn't have that 20-year use agreement, that pad would have just rusted away in the salt air. What an amazing use of NASA's facilities to make our nation better. You know, people talk about government space and commercial space. There's only one space up above us, and if we want to be successful as a nation, we need government and commercial space integrated together. The commercial space makes us stronger. Boeing, I talked about the Starliner. Here you can see it in testing the command and service module. They've done all the parachute testing. They're getting ready for an abort test out of White Sands, New Mexico. Right now it's scheduled for November 4th. And then they are trying to fly on December 17th an uncrewed flight to the International Space Station, hoping for a crewed flight next April. But again, on both Boeing and SpaceX, we still have a lot of work to do to certify those spacecraft.
50 years ago, we went to the moon. We called it Apollo.
What many people don't know is that Apollo had a twin.
She was a woman named Artemis,
goddess of the moon.
We are returning to the moon.
as a new generation of explorers.
This time to stay.
And to prepare to achieve humanity's next giant leap of sending the first human missions to Mars.
We believe our course will redefine what is possible.
That we will discover life-saving,
earth-changing science.
And that the challenges ahead will inspire generations.
This is our manifest.
For all who wondered if we could return.
For all who dreamed of pressing beyond.
This is your calling.
We go for all of America.
We go.
We go as the Artemis generation.
We go.
So we are going. We have been charged by the president through the vice president to put the next man and first woman on the moon by 2024. And we got a lot of work to make that happen in the next 5 years. So what is the Artemis program? So Moon before Mars. I'm a huge proponent of going to the moon before we go to Mars to prove the systems that we need in order to operate in deep space and keep crews alive. Right now, a Martian mission is 1.5 to 2 years. It's 6 to 8 months to get to Mars, another 6 to 8 months on Mars for the planets to align for a 6 to 8 month trip home. And I've seen studies that say you have to have as much as 14 to 18 metric tons of supplies and equipment pre-staged on Mars before you can send humans to keep them alive. We have a lot to learn about keeping humans alive in space, in deep space for that long from an operational point of view, but more importantly, to prove the systems that we need. The space station has been a superb engineering testbed to prove those systems, but how much better to operate in and around the lunar surface and prove those systems when you're only 2 or 3 days from home if you have a problem as opposed to 6 to 8 months or more. So that's why we're going to the moon. We're going to the moon because the moon is the stepping stone to Mars. But we're going to the moon in a different way this time. We are not going like we did during Apollo for a 2 or 3 day camping trip. We are going together with our commercial and our international partners in a sustainable way. And it's that sustainability that is important for us to be successful. So you heard talking in that video, Artemis, the twin sister of Apollo, and that's the name for this program, and are charged to be there by 2024. So we're going to put this gateway in this distant retrograde orbit around the moon that allows access to anywhere on the lunar surface, not just the equator where the Apollo programs went. And where we want to go is to the South Pole, because we have found that there are tons of water ice on the South Pole. What's water? It's hydrogen and oxygen. It's air to breathe. It's fuel. It's critical for our survival. So we've already let the contract for the power propulsion element and for the habitability module and docking module, and we're going out with the contract for the human landing system. Now, this is the same plan we had to get us there in 2028, all right? But we've accelerated it to 2024. To do that, we need more money. The plan that we laid out was based on NASA's current budget, previous budget. So in this 2020 budget submit, the president asked for an amendment of $1.6 billion more for NASA to help make this happen. But we need that kind of support through 21, 22, 23, and so on if we are going to make it by 2024. This is the Artemis 1 flight. It's going to launch without crew, and I'll talk more about it. Right now it's scheduled for late 2020, early 21, and it's going to check out the Orion spacecraft in that distant retrograde orbit around the moon and back to Earth. So Artemis 1 is right now 2020 to the moon without crew. Artemis 2 is 2022 with crew to the moon but not landing. And then 2024, the gateway's in place, and we launch Artemis 3 to the moon and send next man, first one, down to the lunar surface. To do that, we need this power propulsion element, electric power propulsion. That's been, contract's been let for that. The pressurized module, this is a small habitability utilization module with a docking port on it. And this one, we just went out with the RFP for the human landing system that allows transfer and descent to the lunar surface and back. So the Orion capsule will dock with the gateway in space, go down to the moon, and then come home. Again, why go to the moon? All the technologies that we need to develop while we are there. You know, we're working on solar electric propulsion, cryofluid management on the moon, lunar dust mitigation, huge issue. You know, we want to do in situ resource utilization, utilize that water ice, utilize the soil, lunar surface power. There's all kinds of stuff that we are going to learn by putting humans on the moon in a sustained way. And then have the ability, you know, this gateway, our international partners are going to be a part of it also. What you saw was phase 1, all right? And then the internationals are going to come on and it's going to grow. But it's not going to be the space station that we have around the Earth. It's much smaller, and it's not going to be permanently crewed. It'll be human-tended. You know, they'll go up there for periods of time and then leave. But a great stepping stone. And the sooner we get to the moon, the sooner we can go on to Mars. And accelerating it is really important. So how are we going to get there? Artemis 1, the Space Launch System. This rocket, the core stage, is built by Boeing at the Michoud facility in Louisiana. It's the same diameter as the shuttle external tank, 27 feet. It utilizes liquid hydrogen as the propulsion, liquid oxygen as the oxidizer. It utilizes 4 space shuttle main engines. They're now called the RS-25. We have 16 of these engines that were left over after the shuttle program. They've been in storage at the Stennis Space Center in Mississippi. They've got new engine controllers. They've been totally refurbished, and they're ready to go on SLS. The solid rocket motors, these are the same steel casings that we used for the space shuttle. And we have enough for 16 flight sets, 4 flights, let's see, we got enough for 4 flights. They're not 16 sets, so 8 flight sets. These are 5 segments. The shuttle, this right here, that's 1 segment, all right? So the shuttle had 4 segment solids. This has got an extra segment added, so they're 5 segment solids. They've already been certified, and that'll provide even more thrust for this vehicle. Now, this is the Block 1 vehicle. It's utilizing an interim cryopropulsion upper stage. We're going to have a new upper stage that uses 4 RL-10 engines that'll give us better performance for what we actually intend to get to in the end. This is High Bay 3 in the vehicle assembly building. It's ready to go. All the platforms are installed. Unlike Apollo and Space Shuttle, where the platforms were unique to that vehicle, these platforms, and there's 10 of them in there, if you notice this line right here, all right, that's actually an insert. So as this rocket evolves, as the outer mold line changes, we don't have to change out all the platforms. We just change out this insert. And these platforms are adjustable 8 to 10 feet up and down. So when we go from the Block 1 to the Block 1B with the enhanced upper stage, we have to add 3 more platforms because it's a taller rocket and have to adjust some of the lower ones. As we add new solid rocket motor casings, when we go to the advanced solid rocket motor, all we have to change are the inserts, not the entire platforms. Very evolvable. The mobile launcher, this is out at the pad. I'll show you a picture. This thing is like moving a skyscraper. It weighs, what is it? I think it's about when the rocket rolls out, it's going to be like 21 million pounds. We're talking about 6 million pounds for the crawler transporter. This thing's about 12 million pounds, if I remember right. It's huge. It's out at the pad right now, and it's going through final verification and validation testing. And in November, it's going to roll back into that high bay in the vehicle assembly building, and the next time it rolls out to that pad, there's going to be a Space Launch System rocket on it for that first Artemis 1 test flight. The pad itself has been totally refurbished. This looks like just a mound of concrete and earth, and that's a whole complex underneath there. In fact, it's over 3 miles from there back to the Launch Control Center, and there's a tunnel that runs back there. And it was full of copper wire down underneath there and in the tunnel and everything. It's all fiber optics now. We pulled all the copper wire. We made $620 million in scrap off the copper that we reinvested back into the project. But it's got a refurbished water sound suppression system, state-of-the-art lightning protection, refurbished propellant distribution system, a refurbished and improved environmental control system. It's ready to go. I tell my team all the time, and I really mean this, KSC will not be the reason we don't launch on time. We are going to be ready. We are also responsible for recovery of the spacecraft out off the Pacific, and we've already recovered the first one that came down, and I think it's really cool. So it was the USS Anchorage that recovered, a Weldeck ship that recovered the first one, and my son's an Osprey pilot in the Marine Corps, and he made the first Osprey landing on the Anchorage when it was commissioned up in Alaska, and we got to use it first recovery of Orion. I thought that was kind of cool.
Ignition. And the Minotaur launch vehicle is carrying an AA-2.
10 seconds. We will see the abort.
Okay, this is the abort system pulling the capsule off the rocket. You're going to see it go for a little bit, then it's going to reposition itself to eject the capsule.
Reorientation. Settling phase.
There you go. And then the parachutes would have deployed. So this was a Minotaur rocket that had fairings on it to what the second stage was on the Orion SLS combination. And it was a flawless abort test last July. Everything worked perfectly. This is firing room 1 in the Launch Control Center. It's ready to go. The one holdup that I have, and it's always the software, we still have to complete all the software that we need to launch the Orion and SLS. And we've got one more iteration, another software drop that we have to make, but we will be ready next spring with the final software load. And one of the things I'm really proud about, you saw her picture in that video clip, but the launch director that is going to give the go to launch SLS and Orion on Artemis 1 is Charlie Blackwell Thompson, and she's NASA's first female launch director. The Launch Services Program I mentioned, they procure all of NASA's expendable rockets for our science missions, and they've helped NPS here launch some CubeSats into space. That's my Launch Services Program that enabled that. The last launch we had was ICON to study the where space weather meets Earth weather, up in the difference between the ionosphere and the stratosphere, and that was a successful launch. The next big one coming up here is this Mars 2020 rover, another rover the size of the Curiosity rover that's on Mars that we're going to be launching next summer. Here's just a quick shot.
1, drop. Pegasus away.
Yeah, unfortunately, the video cut before the rocket fired. It got really bright, but that was launched from on a Pegasus rocket dropped from an L-1011. That was Northrop Grumman Innovative Services. They used to be orbital. And that mission is great. So exploration, research, and technology. We are an ops center, but we do research and technology also. The Ames Research Center out here in California is responsible for all the animal rodent research. The Johnson Space Center in Houston is responsible for all human research in space. And we are responsible for plant research. And the big thing that we do is called VEGI. And it's on the International Space Station right now, the Advanced Plant Habitat. And it's really critical that when we go on to Mars, that we have not just processed food, but fresh food. And there's a psychological aspect of growing food in space, growing plants in space also in that harsh environment. We are also responsible for all the spare parts on the International Space Station. They're stored at KSC. We process all the payloads that get shipped to the various launch sites when cargo goes up to the International Space Station. And in situ resource utilization. When we go to back to the moon and onto Mars, I want surface operations on the moon and Mars. What we do at KSC, I want us to be responsible up there also when it comes to processing and launching vehicles. So we're heavy into in situ resource utilization. As an ops center, you know, you wouldn't think that we'd be that great in technology, but we won a Federal Labs Consortium Partnership Technology Award last year for our autonomous flight termination system. So in the past, when Jim and I flew on the shuttle, it had a termination system on it, and we used to go over to the range and talk to the guys that pushed the button and show them pictures of our kids and make sure they knew who they were blowing up before we launched. But now it's all automatic, and I'm personally a fan of an automated flight termination system. The computers are so much faster as it's drifting. If it were to be drifting toward the edge of the envelope where they were going to have to push a button to destruct it, a computer knows if it's going to be able to correct and get back or not quicker than a human. And then we led the agency in technology transfer last year with 18 patents that were transferred, and that was pretty cool. So a little bit about me, because I know you guys, I am so blessed to have gotten to be an astronaut when I did. I applied in 1984. I was not selected, and I was fortunate enough to get selected in 1985 the next year and had a chance to fly those 4 awesome missions Captain mentioned. When I got selected, the year I didn't get selected, there were 3,500 applicants and they picked 17. This last class that was recently selected, they had 18,600 astronauts and they picked 12, or applications, and they picked 12. So competition has become much greater to be an astronaut. And when I was chief of the astronaut office, I had 115 astronauts working for me when I included the international partners. Today, I think there's like 44 active astronauts in the astronaut office, so it's become much more competitive. We're just not flying as much. And I'm hoping with the advent of commercial crew, we are flying more frequently, getting more folks up to the International Space Station, and we're preparing for that big step of exploring further. That first mission, Ulysses, STS-41, we deployed Ulysses into polar orbit around the sun. It was on an inertial upper stage. We fired it out to Jupiter. It went over the north pole of Jupiter. Jupiter flung it out of the ecliptic plane with a gravity assist, and it went into a 5-year orbit around the moon. Had 11 experiments on board to study the polar regions of the sun. And what's really cool is it was designed for one pass around the sun. It worked for 18 years, and it got to see the sun at both a solar minimum and a solar maximum. My next flight, I was piloted Discovery again. That was a classified DoD mission. We deployed DoD-1. My third flight, I commanded Columbia on a science mission. We had a laboratory in the payload bay, and we set the record for the longest space shuttle mission, which later got broke. And if I had to pick a favorite, you know, you're not supposed to pick favorites, right? It's like when they ask, who's your favorite child? I have 2 boys and a girl. And you shouldn't have a favorite, but I do. It's my daughter. Everybody knows that, right? Well, if I had to pick a mission, I'd have to pick this one. To be able to go up and put the space station together and be the first crew inside and fly with Dr. Newman, it was just absolutely awesome. So this is from my first command, my third flight. This is a little bit about what it's like to fly on a space shuttle.
I'd like to wish you all a very successful 2 weeks on orbit, and with that, close and lock your visors and initiate O2 flow. Roger, thanks, Randy, and initiating O2 flow. Okay, everybody, tabs in, visors down, CO2 on. Better start with the shake of your life here. Roger, roger. Roger that. Houston, Columbia, roll program. LVLH. Roger, roll, Columbia. Over first stage. That is that cool. Oh, wow, look at that. Throttle. Great. Coming back. 61. I see a 3 at 67. Roger. Over second stage. Keep going. Welcome to space, guys.
We do an excellent job, as you know, documenting the changes in the Earth on our shuttle missions. And the Earth is constantly changing, and we want to ensure that we have the best pictures possible. We've covered the southern U.S., Tokyo, and Germany now on this flight.
8 Q bars, 2, looking for 8.
We're getting a bright pink-white glow around the whole front of the vehicle now.
And we're in a fireball.
Out the overhead window, I'm looking through a mirror, and I can see the plasma just building and collapsing in a bright white flash down the middle of the vehicle.
This plasma is crazy.
It's like little pieces of vehicle flying off in front of us there. 390 miles from home. We're breaking out of the heating here. I can see the sun on the horizon. 1.2 Gs, folks. Descending through 76,000 feet at 270 indicated.
Have a good HUD. I guess Central Florida got a wake-up call.
Approach and land.
Body flap coming to trail.
Here's the maneuver. Ready?
Ready. Columbia, Houston, on glide slope on 1 surface winds, 15084.
Roger. Maneuver complete.
500, 400.
Gear.
Gear's coming.
Speed brake 25.
Okay. On the ball bar.
100.
Gear down.
50 and 250. 40 and 235. 30, 25, 15, 10, 5, touch. Speed brake, waiting for 179. 179, arm and deploy.
Shoot.
Coming.
Gear rotating.
I see 1, 1, 1.5, 1, 1.5, and touch.
I think we're there.
Okay, brake ISOs are open. 120 and 6, 110 and 5.
Stand by to jettison.
Roger that. 105, 90 and 6, 80 and 5, 70 and 6, 60 knots. Chute is gone. 50 and 5, 40 and gaze off.
Houston, Columbia, we'll stop.
Great job.
Great job, Bob.
Roger, well done.
It's great to be home. We're all feeling great, and it was a super flight, and thanks to everybody for all the fine help.
So that ride uphill, no simulator can prepare you for that. It is just a sense of speed and acceleration. You saw that shaking and vibrating when you're on those solid rocket motors. You're being pushed back in your seat. At max Q, the engine's throttled back to 72% to keep from exceeding the 3G limit on the orbital, the structural limit of the wings. And when you get through that, you throttle back up. And you didn't feel it throttle back, but they throttle back up to 104%. You're pushed back in your seat. And then 2 minutes and 5 seconds into the flight is when you come off the solids. It feels like you slowed down. You're just not accelerating as fast. And you heard that bang, and you see that flash out the window as the solids separate away. And then it's just as smooth as can be on those 3 main engines. It's like electric drive. And you continue out to, at about 7.5 minutes, you hit that 3G acceleration limit again. You're being pushed back in your seat. It feels like, you got this gorilla sitting on your chest. And then at 8.5 minutes, you hit MECO, main engine cutoff. You're going 17,500 miles an hour and the engine's shut down. And you come forward in your straps. Again, it feels like you stopped, but you just stopped accelerating. And you look out and you can see the curvature of the Earth. At that point, you're about 65 miles above the Earth. You continue to coast out to your apogee. That's where you burn the OMS engines to circularize your orbit. And it's just absolutely amazing. You saw a little bit of the view of the Earth. 220 nautical miles altitude, you can see about 1,500 miles in any one direction. But what you notice is when you're on the sunlit side of the Earth, first off, the sun is so bright, you can't see any of the stars. Your irises shrink down, and all you see is this black void of space. It is the darkest, deepest black you can imagine. Nothing on Earth does it justice. And you see the curvature of the Earth and this thin little hazy line over it. That's our atmosphere. That's all that's protecting us from that harsh void of space with its ultraviolet radiation and extreme temperatures. When Jim went out and did his spacewalks, he was wearing that EVA suit with his liquid cooling garment and multiple layers to protect him against micrometeorites and temperature extremes where when he was in the sun it was up to 350 degrees Fahrenheit, and when he was in the shade it was minus 150. That is the environment that we have to learn how to live and work in. So that last flight that Jim and I flew on, you can see Dr. Newman there, going on out to Endeavor. And Nancy Curry was my arm operator and mission specialist too, our flight engineer. She had a PhD in industrial engineering. She was a helicopter pilot in the Army before she got her PhD and came to work at NASA. She lifted Node 1 out of the payload bay, and she had roughly an inch to less than an inch of clearance on either side as she lifted it out, and I kidded her. I didn't know anybody could move the arm that slow as she was lifting it out to make sure she didn't hit anything, but we picked it up and we attached it to the orbiter docking station. And then we rendezvoused in space with the Russian FGB, Functional Cargo Block Zarya, which means sunrise in Russian. You can fly the space shuttle in space from either the aft flight deck or the commander seat. In the airplane mode, landing at either of the front two seats can fly it. You have two controllers. The rotational hand controller in your right hand does pitch, roll, and yaw, and the translational hand controller goes in, out, left, right, up, down. It translates the orbiter forward and back, side to side, up and down. It's very difficult to fly 6 degrees of freedom at once, so we program the digital autopilot here to maintain the attitude, and then all we have to worry about are the translations during the rendezvous. So that's the Russian functional cargo block, the view out the overhead window with the node attached to the docking station, and here you can see Jim and Jerry out on one of their 3 EVAs connecting all the power and data connectors, and the Unity node with the FGB. And then we were fortunate enough to be the first crew to go inside the International Space Station. Now here's a trivia question for you. If you ever get asked, who is the first person to enter the International Space Station? It's a trick question, because there was no first person. When it came time to enter the hatch, and I didn't even tell the crew, the media kept asking me who was going to be first. When it came time to open the hatch and go in, I said, Sergei, get up here. We had a Russian crewmate, Sergei Krikalev, more time in space than any other human at the time. I said, Sergei, get up here, and I grabbed him. And if you look at any of the videos, Sergei and I enter all the hatches side by side. I felt if it was going to be an International Space Station, we needed to enter as an international crew. So I had the privilege of being the first American, and he was the first Russian. And there you can see me inside Node 1. It was all nice and neat and clean. It doesn't look like that anymore. I left it very Marine-like when I left. And this is what the space station looked like when we left it. Those 2 little modules sitting up there, the core of the International Space Station. This is what it looks like today. This is overhead right now with a crew of 6 on it, the size of a football field. You've got the European laboratory, Columbus. You got the Japanese laboratory, Kyubo, which means hope. This is Node 2. This is the U.S. laboratory, Destiny. Node 1 that we took up is there. This is the FGB. This is the Russian Zvezda, the service module for them. And radiators to reject heat, solar arrays for collecting electricity for the batteries. It is an awesome, awesome piece of machinery up there, and I'd give anything to be able to go back again. It'd just be so cool to go see it now that it's done. So that, in a nutshell, is what's going on at NASA. What I want you to leave here with is a couple of things. First off, we have an outstanding future in space, all right? We are a world leader, and we are going to continue to be a world leader. And one of the things that I really want to see happen before I leave the Kennedy Space Center are U.S. astronauts flying on U.S. rockets from U.S. soil to the International Space Station. We are going to make that happen within the next 6 to 8 months. I guarantee it. I also want you to know that our future is outstanding. As amazing as our last 50 years have been, all the things that we have accomplished in space, I believe our next 50 years are even going to be better. And I got to tell you, I have a rule that all the 50% of the people that we hire at the Kennedy Space Center have to be fresh outs. And I'm trying to lower the average age at KSC because we still got a lot of older shuttle folks that are working down there. Nobody wants to leave, right? It is just so great. I love coming to work every morning. Shoot, I'm really old. But I get up every morning and get to drive across the bridge onto the Merritt Island to the Kennedy Space Center, seeing the sun come up over the Atlantic Ocean, driving to work in a 144,000-acre wildlife reserve, making a difference for our nation. You know, NASA has been #1 on the Federal Employee Viewpoint Survey for the last 8 years in a row. Last year, KSC was the #1 center of all 10 NASA centers. And why is that? I think it's for a couple of reasons. First off, we have what we call the NASA family. We all look out for one another, right? And you guys know what that is in the service. It makes a difference. But also, if we have a meaningful mission, you know, when we go home at night, we know we didn't just make a difference for Kennedy, the state of Florida, for our nation. We're making a difference for humanity. And I think it's very important that we as a people establish a presence beyond our home planet within our solar system. John Young was chief of the astronaut office when I got selected to be an astronaut. Man, I couldn't believe it. I'm working for John Young, one of my heroes. Gemini, Apollo, first space shuttle mission. And John used to say, single planet species will not survive. There is going to be some event at some time in the future that, just like it wiped out the dinosaurs, it's going to come after us, right? And if we don't know how to establish ourselves off our home planet, we as a species will not survive. So I think this is critical. It's in our DNA. It's our nature to explore. And I can't imagine not being a part. I thank the Naval Academy for giving me the skills, Naval Test Pilot School helping to be a test pilot to prepare me to be an astronaut, but I can't think of anything that I would have rather done. So with that, I got a little time for some questions before I have to turn you guys loose. Anybody got any questions about anything and everything, being an astronaut or NASA related? Answered all your questions. All right, here comes one.
Afternoon, sir. Major Matt Bowman, Information Warfare Systems Engineering. Sir, I know your responsibilities lie with Kennedy Space Center, but as we're going up to the moon and we're gonna be there for a while, could you speak to who within the government has responsibility for sustainability and making sure that we don't use up all those resources on the moon and then turn it into kind of what we have here?
Yeah, so there are international agreements. There are international agreements on what you can and can't do in space. There's tons of water ice up on the moon. You know, yeah, that's above my pay grade. I'm not worried about using them up. I'm worried about getting there. And we got a lot of work just to get there. But you know, you bring up a great point. I think from a future, how we expand beyond our home planet. I think one of the things that's really important is the model that we have on the International Space Station. You know, we are partners with the Russians, all right? And we don't always get along, but in space we get along. We work as one. And I believe when we leave our home planet, when we establish that presence and we go on, we need to do so as not the people from the United States, but the people from planet Earth in an international cooperative effort. And right now, all our partners on the International Space Station want to be partnered with us as we do Gateway, as we go back to the moon. And the Russians want to be part of that partnership also. So whatever we do, I think it's important to have agreements in place that we do it in a cooperative effort. One of the hardest jobs I had when I was working in the space station program was getting the agreements, essentially treaties signed for the International Code of Conduct on the International Space Station, getting everybody to agree to what the rules were and how we were going to do that and who was responsible for what and what the legalities of it were. And if any of you dealt with any of our international partners, you know, our Japanese partner, first of all, it's hard enough to get the Russians to agree to something, but then you have the Japanese partners are, you know, they're saying, hi, yes, yeah, hi. And that doesn't mean they agree, they just heard you. And then it goes back, and they have other people in Japan that have to pass these treaties and agree to it, and they don't necessarily agree, so you got to renegotiate things again. But I know we can do it. We did it on the International Space Station, and I think it's great that we're continuing to work the way that we do up there.
Thanks very much for coming out here. I really appreciate it. Can you talk a little bit about what you see as the possible impact of orbital debris on the human spaceflight program? Obviously, LEO is a relatively small place, and there are hundreds of thousands of pieces of debris and micro debris. I mean, do you think we're going to get to a point where the carrying capacity is just too much and too difficult, and we are going to have to limit our human spaceflight activities?
So there are rules on, every time my launch services program, when we launch an expendable rocket, they have to dispose of the stage that took the satellite to orbit. And they have to have enough propellant so that they can do a deorbit burn that brings it out of orbit and brings it down, or sends it out further away from planet Earth so it does not become debris. That's part of our rules. You know how you get those annoying rock chips in your window? Every time the orbiter came back, they'd change out 3 to 5 of the windows on the orbiter. I had one on that long duration flight. It was huge over on the pilot's side. Big chip out of the window, starburst, and I didn't worry about it because it was on his side. But, every mission that I've been on, we had to do some sort of a maneuver to avoid a conjunction with orbital debris. And it's a huge problem. And it's getting more so, especially with these companies that are talking about putting up these mega constellations of small sats. So it is a concern. And I don't know how we're going to solve it yet, but I think it's something that absolutely needs to be looked at and taken care of. You got it.
Adam Sharma, CS Department. Sir, what do you see as the biggest obstacles to the moon mission and to the Mars mission that you mentioned?
So biggest obstacles are, one of them is going to be radiation, all right? Being able to protect the crew from the radiation. See, that's why I need to go, because at my age, by the time I get cancer, it won't matter. But no, radiation is going to be a huge problem. I think that's going to be one of the challenges. It's going to be having the reliable systems. Robots are easy to send. Humans are hard. You got to give them a pressurized environment, air to breathe, scrub the CO2, give them food, take care of all their waste, and everything has to be very reliable and work well. And I think developing those systems, learning how to operate away from planet Earth, where the crew has to have more autonomy, where you can't respond immediately, where you can't get home. They got a problem on the International Space Station. They jump in the Soyuz or one of the new vehicles, and they're home in a few hours, all right? We're not going to be able to do that when we expand beyond our home planet. So that I think, the life support systems to reliably provide for the crew, and that goes into radiation. It's taking care of humans in space. All right, so here's the deal. You guys, there's some other stuff that has to go on in here. My time is up. What I'm going to do is I'm going to go back outside up into the foyer up there, and I will be happy to take any more questions or talk to any one of you. I thank you for your attention. You guys are awesome. I appreciate your interest in education. Never stop learning. Never stop exercising. I'm an avid cyclist, and I'm going to keep going as long as I possibly can. It's really important. But don't let yourself go stale. Continue to learn. Even after you get your degree here and you get back in the fleet or wherever you're going, continue to learn. Thank you.